We want to determine the limit if it exists. Notice how here we're determining a limit of a function of two variables. So for review, as x comma y approaches the point a comma b, the limit of f of x comma y is the value L if the limit from all paths approaching the point a comma b exist and are equal to L. So if this surface is the graph of f of x comma y, and we're trying to determine this limit, and it's equal to L, that would only be true if the limit from all the paths shown here, or any potential paths, would also give us a limit of L. So notice how potentially there's an infinite number of paths to consider. However, if the surface is smoothly continuous over a region containing the point a comma b, we can find some of these limits by performing direct substitution. So going back to our example, notice how if we try to perform direct substitution, we'd have the indeterminate form of 0 divided by 0, which means to determine this limit, or determine if it exists, we'll have to determine the limit from several paths and see if all of those paths give us the same limit. Now I should mention it is often helpful to have three-dimensional graphing software to analyze the graph of our functions. I provided the graph here below. By analyzing the graph, notice how it does appear that as we approach the origin, let's say along this path and this path, the limits may be different, which indicates this limit probably is not going to exist, but we'll have to show this by determining the limit would be different along different paths. If we don't have graphing software to analyze the surface, then we would just select paths approaching the origin, and several of the more common paths are shown here on the xy coordinate plane. We can approach the origin along the x-axis, or y equals 0, along the y-axis, or x equals 0, as well as the lines y equals x, or y equals negative x, or even y equals x squared, or y equals negative x squared. But probably the most two obvious paths approaching the origin would be along the x and y axes, or y equals 0 and x equals 0. Let's begin by considering those two paths. So for the path along the x-axis, or y equals 0, we'll substitute 0 for y in our limit. So we'd have the limit of x comma 0 approaches 0 comma 0 of, again we're substituting 0 for y, so we'd have 5x times 0 divided by x squared plus 0 squared. So simplifying, we have the limit of x comma 0 approaches 0 comma 0 of, we'd have 0 divided by x squared. Notice how when x equals 0, we'd have the indeterminate form of 0 divided by 0, but for all other non-zero values of x, this would be equal to 0, which means our limit is 0. Now be careful here, this does not mean our original limit is equal to 0. This only indicates that along this path, or along the x-axis, as we approach the origin, the limit equals 0. For this limit to exist, all the paths approaching the origin would have to result in the same value of 0. So now let's go ahead and consider the path along the y-axis, where x equals 0. So if we consider the path x equals 0, we'll now substitute 0 for x. So we'd have the limit of 0 comma y approaching 0 comma 0. Now if we substitute 0 for x, notice how the numerator is going to be 0. The denominator would be 0 squared plus y squared, or just y squared. And once again, notice how as y approaches 0, this quotient would always be 0 for all non-zero values of y, and therefore as y approaches 0, this limit equals 0. So now we've shown that along these two paths, the limits are 0, but once again, that doesn't mean this limit equals 0. And because of the graph of the surface, let's go ahead and consider one of these two paths. These two paths are y equals x and y equals negative x. So let's consider the path y equals x. If this limit is not equal to 0, then we know the original limit does not exist. So here we'll substitute x for y, which would give us the limit of x comma x approaches 0, 0 of, again we're substituting x for y, so we'd have 5x times x divided by x squared plus x squared. So simplifying, we'd have 5x squared divided by 2x squared, but this does simplify to the limit of x comma x approaches 0, 0 of, this simplifies to the constant 5 halves, giving us a limit of 5 halves. Notice how this value is not affected by x. So now we've shown along the path y equals x, the limit is not 0, the limit is 5 halves. So as soon as we find one limit that's different, this indicates a limit does not exist. Now you may also want to consider the path y equals negative x. Along this path we can determine the limit would be negative 5 halves. But again, we have enough information now to determine the original limit does not exist. I hope you found this helpful.